Hello guys, can you hear me?
Yeah,
How are you doing?
I'm doing good, thank you.
Um, Today we'll be focusing on measures of position. Now let me ask you, can you see the screen here?
Yeah,
Okay, good, good. Now, measures of position, um, what we do, actually, let me put it this way. They are measures that we use to locate the relative position of data set or a data value in a data set. Now, for example, I'm sure that you guys must have heard of things like percentiles. Let me use that as an example. If your score, let's say your credit score falls on, say, the 25th, 75th percentile, it means that your score is better than 25%, 75% of Americans, The same thing with grades. Now, the measures we'll be looking at, some of them will not be able to finish today, but we continue with them and finish them next week. So some of the measures we'll be looking at include the standard score, percentiles, deciles, and quartiles. Now, we will not spend more time on decile because deciles are, if you have 10 percentile, it is the same as one decile. So when we just focus on percentile, standard score, and quartiles. Now, the standard score represents the number of standard deviations a given data value x falls on the mean. And this is the formula we use for it. Z equals to value minus mean divided by the standard deviation. And we can use that value, we can use x to represent that value, and this mu to represent the mean, and the delta symbol to represent the standard deviation. Remember that in statistics, we use mu for the population mean, we use x bar for sample mean, delta square for population variance, S square for sample variance, delta for population standard deviation, and S for sample standard deviation. So now the standard score is simply, to calculate it, we use x minus mean divided by the standard deviation. We're going to do an example so you can see how it is calculated and interpreted. For the percentile, divide the data set into 100 equal groups. Now, this side divide it into 10 groups. So that's why we focus on percentile, because um, one decile is the same as 10 percentile. Two decile is the same as 20 percentile. So we're not going to worry about this side. We just focus on percentile. In any case, percentile is the one that is used most of the time. Quartiles divide the data set into um, 4 groups separated by Q1, Q2, and Q3. I'm sure you must have heard of some. What will give you an idea of what quartile is? Yeah, something like, in America, public, I mean, publicly traded companies, big corporations like Walmart, Apple, are required to report their profits quarterly, every quarter. That's every 3 months. And some colleges run quarter system. Instead of semester, they have quarters. So that will give you an idea what quartile is. There's mid quartile, we learn how to calculate it, which is first quartile plus third quartile divided by 2. Then we'll be looking at outliers. Yeah, there are some values that often stand out from the group. We'll be looking at them as well, but not today. Yeah. Then we look at exploratory data analysis. Now let us see how to compute this score. I'll use this example. It says a student scores 60 on a math test that has a mean of 54 and a standard deviation of 3. And she scores 80 on a history test with a mean of 75 and the standard deviation of 2. Suppose she also scores 65 on a biology test with a mean of 75 and the standard deviation of 2. On which test did she perform better? Okay. So I'm gonna put okay, sorry. I'm gonna put some of these things here so that we put the values together and calculate the z-score for the three um courses. I'm gonna move this one. Yeah. So now let's say that he scores 60 on a math test. So this one is for biology. I'm gonna make this one biology. Okay, I'm gonna say it before I continue. Okay. So now I say that this student is on a okay, on a math test, she scored 60 on a math test. So X is 60 here for maths. Okay. Which has a mean of 54. Mean for maths is 54. And standard deviation for maths is 3. Now, for she scores 80 on the history test. It's a history. 80. X is 80. And the history test has a mean of 75 and a standard deviation of 2. And 2 as the standard deviation. Now it says, suppose that she scores 65 on a biology test. X is 65. And then it has a mean of 75 and the standard deviation of 2. So actually, let me change this to mean of 85. What? You said 75. Okay, 75. 75. And the standard deviation of 2. So he said, in which test did she perform better? Now, to do that, we're gonna use this formula. Z equals X minus mean divided by standard deviation for each of them. Okay. So I'm going to bring it down. Bring this down so we can be looking at it as we calculate them. There's Z score. This is the formula we'll be using right here. Z. Now, for biology, for maths, Z equals, oh, excuse me, sorry, I'm gonna write it under. For maths, okay, it will be equals okay, X is 60 minus mean of 54. You can see 54 for mass divided by standard deviation of 3. And that will give you the z-score for maths. Let me write this down so we can put it on the calculator. I got 60 minus 54 over 3. Okay. I'll take you to the calculator so we can calculate this. Okay, the calculator is somewhere here. Good. So we got 60 minus 54 divided by 3 as a standard deviation. 2.0. 2.0. We usually write the answer in 2 decimal places, 2.00. Now, for history, the z-score will be Z equals to our history, our X is 80 with a mean of 75 divided by the standard deviation of oh sorry, of 2 right here, 2. So I'm just gonna put this place. I'm gonna write 80 minus 75 divided by 2. Yeah. Um, we got 80 minus 75. 80 minus 75 divided by 2. 2.50. 2.50. Okay. Um, okay. So for the um, biology, okay. Now, Z now becomes equals, biology says X is 65 minus 75 divided by standard deviation of 2. So we got 65 minus 75 by 2. So we go to our calculator. Okay, we have 65 minus 75 to get negative 5.0. Negative 5.0. Okay. So you can see that the z-score for mass is this 2.0. So the student score, this is how we say it. We say that the student score in mass is 2 standard deviations above the mean. Her score in history, um, her score in history is right here. You can see right here. It's positive, right? 2.5 is 2.5 standard deviations above the mean. So it's both of them are above average. Uh, Above the mean. Okay. But her score in biology is negative. That means it's below average. Her score in biology, her score in biology is 5.0. Okay. Standard deviation. But this time is below average. Below, because it is negative. So the question was, um, on what test did the students perform better? Of course, he performed better in history because the z-score is above average, even though this one is above average mass, but this one is higher. So the student performed better in history than in any other subjects here. Any question on this? Any question? Okay, excellent. No question. Now, we can now go to percentiles. Like I said, percentile divide the data set um to into 100 equal parts. So let us see how to calculate the percentiles with this question here. The question says, a teacher gives a 20-point test to 10 students. The scores are shown here. Find the percentile rank of the score of 12. Excuse me. Find the percentile rank with a score of 6. Find the percentile rank. Find the value that corresponds to the 25th percentile. That is, locate 25th percentile. The other way of asking this question is to say, locate the 25th percentile from the list. They say, find the value that corresponds to the 60th percentile. Now, when calculating percentile, of course, we can use Excel to do it as well, but usually the score, sometimes the answer you get from Excel for percentiles might be different from the answer you get from direct calculation with uh, the manual method. That's why for percentile we're going to stick to this method. So first thing you do is to put the numbers in order, and I did that here. Before I do that, I want to show you these formulas. To locate the percentile, use this formula: percentile location number n times p by 100, where um PL is location number, then n is total number of values, and p is the percentile of interest. And for percentile rank, you're gonna use this one formula here. Number of values below x plus 0.5 divided by total number of values times 100. Note that this 0.5 is part of the formula. If you're moving from the continuous to a district, you put this correction factor. Okay. So now, based on this formula, let's answer this question here. First thing you do is to arrange them in order of magnitude from the smallest to the largest. You can see they are now arranged. Now let's answer the first question. The first question says, find the percentile rank of the score of 12. Now let us find the total number of values we have here. How many? 10 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our n, total number of values is n is 12. Sorry, 10 students. Okay, and we are looking for the percentile rank of the score of 12. So what is the position of 12 here? 1, 2, 3, 4, 5, 6, 7. Okay, sorry. 1, 2, 3, 4, 5, 6, 7. So now, how many values are below 12? See? We see because it says here number of values below 12. So 1, 2, 3, 4, 5, 6 numbers are below 12. So our x is number of values below 12 is I'll call it yes, because our x is 12. So number of values below 12 is 6 of them. So let's put this in the formula. Percentile becomes let me write these numbers down. Number of values below 12. Number of values below 12. That's below 12. That's 6 of them. Because you say 1, 2, 3, 4, 5, 6 of them. So we can now calculate the percentile by using number of values below x plus 0.5 divided by total number of values times 100. So this is part A. I'm gonna call it part A of the question. So we can have a percentile here. Percentile equals, I'm gonna put it in parentheses because I'm gonna do two math to add these two values. Number of values below x, that is here x is 12, is 6 plus 0.5 divided by total number of values is 10 of them, 10 students, times 100. That will give you that will help to locate the percentile. That will give you the percentile rank. Sorry, give you the percentile rank. Okay, of 12. Now, let's put this in the calculator. 6 plus 0.5 divided by 10 times 100. Yeah. So I'm going to take you to the calculator. Okay. 6 plus 0.5 divided by 10 times 100. Give me 65. 65. 65. So that means that, what does this mean? I'll call it 65th percentile. So that means, how do you interpret this? It says here that the score of 12 falls in the 65th percentile, and the student with that score perform better than 65% of all students who took the test. Any question on this? Hello, class, can you hear me?
Yeah.
Any question?
No.
Okay, good, excellent. Now let's answer part B says, find the percentile rank of the score of 6. So in this case, that is part B. Part B, our L66. Again, it is total number of values is 10. Okay. The number of values below 6. See them here. 1, 2, 3 of them. Okay. I'll say the number of values below 6 equals 3 of them. So we can now plug this in to find the percentile rank. So percentile rank of the score of 6 becomes 3 plus 0.5 divided by total number of values of 10 times 100. That will tell you the percentile rank of 6. So I'm going to take you to the calculator. 3 plus 0.5, just, we have it already on the calculator. I'm just going to add, change it to 3. 35. So 35th percentile. 35th percentile. Which means that the score of 6 falls in the 35th percentile. And any students who have that score perform better than the 35% of the class. Yeah. Now, having said that, now we can now look at the question. That's where the last two are asked differently. It says here, find the value corresponding to the 25th percentile. That is, locate the 25th percentile from the list. I mean, so this is another way of asking you. You can either be asked to locate the 25th percentile from the list, or to locate the 40th percentile from the list, or they will ask you to find the value that corresponds to the 40th percentile. Okay. For that, we're going to use this formula here. Location not formula. PR. Where R is location factor. Actually, I would say P represents the percentile I'm trying to locate. So in this case, say find the value that corresponds to the 25th percentile. So to do that, we use the formula P25 will be, I say n times P over 100. In this case, how many numbers we have? N 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 students. So N is 10. I asked to locate the 25th percentile. So P is 25. Now, let's do it. P25 now becomes 10 times 25 divided by 100. So taking you to calculator, have, okay, 10 times 25 divided by 100. 2.5. 2.5. Now, if you have a decimal like this one, there's a decimal here. You can see that there's a decimal 0.5. If you have a decimal, just go to the next number, which is, and it doesn't matter whether the decimal is up to 0.5 or not. Even if it's 2.1, go to the next whole number, which is third number. The third number, that's what it means. The third number in from the list. The third number is say 1, 2, 3. The third number there is 5. 5 is the third number in the list. Okay, so it's 5. This means that the score of 5 corresponds to the 25th percentile. Percentile, what it means. So the third number, say. Now, let's look at a situation whereby we don't remember this one. We have a decimal, so it is easy to find it. We just run to the next. No, we didn't even round. Just go to the next phone number. Now, let's see a situation where it doesn't work that we don't have a decimal. Like here, but this is find the value that corresponds to the 60th percentile. So in this case, we have n is 10 and p is 60. So you're looking for the value that corresponds to the 60th percentile. Okay, so plugging it into the formula, p60 equals n times p. Say n times p. N is 10 and p is 60. 10 times 60 divided by 100. So I'm going to just take it to the calculator. Have 10 times 60 changes to 60. It's 6 even. 6 even. 6. So in this case, there's no decimal. So what you're going to do is you're going to do the 6th number plus the 7th number divided by 2. The 6th number plus the 7th number divided by 2. If you look at the list, see 1, 2, 3, 4, 5. This is the 6th number here, and this is the 7th number. So that gives us 10 plus 12 plus 12 divided by 2. That gives us 10 plus 12 is 22. Divided by 2 is 11. So that means the score of 11 corresponds, even though there's nobody that scored it, but the score of 11 corresponds to the 60th percentile. Any question, guys? Any question?
Hi, Professor. I got a question. So,
Mhm.
um, so all of this, because I'm trying to study this, all this, will this be posted on module somewhere?
It's in YouTube. Remember I told you when you go to YouTube, type my name, Joseph Orji, type percentile. It will bring all the videos I made on this.
Oh, okay. All right, cool.
Yeah,
Thank you.
including, yeah, of course. Any other question? I wanted us to stay longer, but I have a meeting. Actually, the meeting is by 1 o'clock. I couldn't, but I'm gonna let you go. But continue. Don't go yet. I want to check your names down, so don't go yet. Continue practicing on this, and on Tuesday we begin from quartiles, quartiles, and hopefully, but it is next week we will finish the data description, and then so that the following week we enter probability. So let me take down your names, and after that you are free to go. Okay. Since there's no question, okay, Miss name. All right, I got your names. I got names. And then I got here. Scroll again. Amari, I got her. Elisa. Got Elisa here. Blessing. Got Blessing. I got okay. Who else? I see it. Gallo. Okay, got Gallo here. Gaskins. Gaskins. Okay, got it. Okay, sent here. Spanish. So, okay. Now, if you don't have any question, I think I have everybody now. Randall, Crooks is Sydney. Then you can leave. Okay, I'll see you on Tuesday, okay?
Thank you. Have a good day, Professor.
You too.
Professor, I got one more question.
Yes, sir. Go
So
ahead, sir.
last class we did also like something like this, and I remember you said you would like put the document on Canvas. Should I just search up that on YouTube also? Because I remember I tried to go through modules to look
Is
at
it
the
the one?
document.
Are you referring to the one we did in class?
Yes.
Yeah, I put it here. I uploaded it here. Remember I told you I showed you the place. I'll upload. I will
Because when
upload.
I clicked it, it just took me to a homework assignment in Pearson. That's why I was.
Okay, now look at it here. It's right here. Right here. You click on the model
Oh.
to bring it to this page. Scroll down. You can see right here.
Okay. All right.
Mhm.
Okay, that's cool.
Mm.
Okay, thank you.
You're welcome. All right, guys. I see you on Tuesday, huh? In the classroom.
Have a good day.
You
Have a
enjoy.
good day.
You too. Okay, bye-bye.